Welcome to chemistry class with Anekwe Christopher GK. In this particular video, we're going to be looking at the topic compounds of carbon. We'll be looking at the compounds of carbon. In the last video, we talked about carbon and things that has to do with carbon. It's allotropes and the physical and chemical properties of carbon. But this video, we are going to channel our attention on compounds of carbon, the carbon 2 oxide and carbon 4 oxide. And it's expected by the end of this video, you are going to learn, you should be able to explain the preparations of carbon 2 oxide and carbon 4 oxide. You should be able to also state the physical and chemical properties of carbon 2 and carbon 4 oxide. And lastly, you should be able to state the uses of carbon 2 oxide and carbon 4 oxide. We'll be taking them one after the other and run it down. First of all, we are going to start by how carbon 2 oxide and carbon 4 oxide have been formed. Generally, when carbon bonds in air, it will produce carbon 4 oxide in excess air. But when there is a limited supply of air or oxygen, there will be carbon 2 oxide. So combustion of carbon produces carbon 2 oxide and carbon 4 oxide. But complete combustion, carbon 4 oxide, incomplete combustion or limited supply of air will give carbon 2 oxide. The equation for the reaction for the two is this. The first one is for the complete combustion, carbon 4 oxide. The second one is carbon 2 oxide, incomplete limited supply of air. Then other method of preparing carbon 4 oxide, remember we are starting with carbon 4 oxide, is when methane is born in air. Actually, it's for hydrocarbons, not only for methane. When carbon 4 oxide is born in air, it will produce carbon 4 oxide and water. So, but we use methane as an example. Every hydrocarbon burns in air to produce carbon 4 oxide and water. Number two method is by the composition of triazo carbonate 4 salts, except that of the sodium and the potassium, or hydrogen triazo carbonate 4 by strong heating. When you do so, you are going to produce carbon 4 oxide. When you use calcium carbonate, carbon 4 oxide will be produced. When you use sodium hydrogen triazo carbonate 4, carbon 4 oxide will also be produced. That is number two method of preparing preparing carbon 4 oxide. Number three is by action of dilute mineral acid. It could be H2SO4, it could be HNO3, it could be HCl. Any of them, when it reacts with triazo carbonate 4 salts or hydrogen triazo carbonate 4 salts, which is something like sodium carbonate or potassium hydrogen triazo carbonate 4, carbon 4 oxide will be formed, as you can see in the equation here. In any of them, carbon 4 oxide will be formed, will be produced. That is number three method of preparing carbon 4 oxide. We can also prepare carbon 4 oxide through fermentation process. When glucose is fermented, it will produce carbon 4 oxide and ethanol. Glucose under fermentation process produces ethanol and carbon 4 oxide. That is number four method. We can now prepare carbon 4 oxide in the laboratory using this setup. That is that of the dilute mineral. Marble chips, which is a calcium carbonate, action of it on dilute HCl will produce carbon 4 oxide, which is carbon dioxide, but it's carbon 4 oxide is the IUPAC name, through downward delivery, or you call it upward displacement of air. The equation for the reaction for that is what we have here. Calcium carbonate, which is that of the chips, action of that in dilute HCl through the test tube funnel here, it will give you calcium chloride, and but our concern is on carbon 4 oxide that will be produced. Now, that carbon 4 oxide produced, in order to get the pure and the dry carbon 4 oxide, it has to be passed through a solution of potassium hydrogen triazo carbonate 4 in order to remove the impurities, in order to get the pure one. But in order to get the dry one, it will pass through conc H2SO4 or fused calcium chloride in order to dry the gas, and it will not be collected through downward delivery, because we know that it's denser than air. And being denser than air, that is why we use it in fire extinguisher. Okay, physical properties. Carbon dioxide is colorless and odorless gas. It does not support combustion. Of course, it's denser than air, which is the third property, is heavier than air, and it is easily liquefied at low temperature with pressure higher than 5 atmosphere. The chemical behavior of carbon dioxide is this. Number one is that it dissolves in water to give triisocarbonate 4 acid, which is an acid anhydride. Carbon dioxide is an acid anhydride, and when it dissolves in water, it produces an acid. And number 2 is that it turns damp litmus paper red because it has an acidic property when it's in water. Number 3 is that it neutralizes base to give salt and water, which is the characteristics of an acid when it gets to water. That is number 3 chemical properties. Number 4 is that it acts as an oxidizing agent. As we can see in the diagram below, it oxidizes carbon to carbon 2 oxide. It oxidizes magnesium to magnesium oxide, and itself will be oxidized to carbon, as we can see it in the diagram above in the screen. Number 5 is react with lime water. With this equation, carbon dioxide reacts with lime water, which is calcium oxide, to form calcium carbonate and water together. And when it lasts for long inside that water, inside the lime water, the equation will become like this. At the end, it turns colorless. Of course, the top part of it, you see that it becomes colorless liquid. Then something will settle under, the particles will settle under, and the top will be colorless solution. Equation is being given. Then the next one is that we need to understand some uses of that. It is used as a fire extinguisher, of course, because it's heavier and denser than air. It is used for that because it doesn't support combustion. Number 2 is that it's used in the production of aerated drinks such as Coca-Cola, 7-Up, and the Pepsi. Number 3 is that it is used as effervescent in certain health salts such as Andrew liver salts. When mixed with tartaric acid and cornstarch, it is used for baking powder. Number 5 is used in production of sodium carbonate by solvent process. Number 4 is that it is very necessary for photosynthesis. And then number 5, it is used when solid. It is called dry ice, which is used as refrigerant. This particular dry ice has some advantages over normal ice we have, which is the ice block. It has some advantages over that. Why? Dry ice produces a greater cooling effect than the equal volume or equal mass of such common ice, which is the ice block we know. This is because the dry ice can provide a temperature of 779 degrees Celsius. Dry ice again, on warming sublimes. It changes from solid to gas immediately without turning to liquid, unlike the ice block we know. But we need to be careful not to handle solid carbon dioxide or solid ice, dry gas. Why? Dry ice. Why? With bare hand, because it causes painful blister similar to those caused by hot objects. Okay, now let's look at the carbon dioxide. Preparation of that in the fume cupboard. There are 3 methods we can use to prepare carbon dioxide in the laboratory. One is through using ethane dioic acid crystal. When ethane dioic acid is being heated like this with conc H2SO4, we'll see the setup, and the carbon dioxide will be collected here through upward delivery. Now, the equation for the reaction is this: the composition of ethane dioic acid when heated will produce carbon dioxide here. And we need to note that conc H2SO4 is a drying agent. It's added there as a dry, we know it's a drying agent, and it is there to remove the element of water, while KOH removes carbon dioxide there. Okay, that means potassium hydroxide. This is in this equation, and it removes the water part of it. Okay, number 2 is that sodium methanoate. We can use sodium methanoate to produce carbon dioxide, and the equation for the reaction is this. Sodium methanoate is this, or you can not only methanoate. Removal of water on it will give us carbon dioxide. Dehydration of methanoate will give us carbon dioxide, or this. 2 of them is removal of water. Then the next one is by reduction of carbon dioxide to carbon dioxide, as we can have it here. Shortly, let's look to the physical properties of that. It's a colorless, odorless, and tasteless gas. It's lighter, slightly lighter than air, and is slightly soluble in water, or insoluble in alkalics. It is soluble in ammoniacal solution of copper-1 chloride, and is a poisonous gas, hence prepared in fume cupboard. That is why we prepare it in fume cupboard. And chemical behavior of that is that it is used as fuel because it supports combustion. But carbon dioxide does not support combustion, but this one does. It is neutral to gas, therefore it does not have any action on litmus paper. It is useful as a reducing agent because it is readily reduced to carbon dioxide, as we can have it here. In this equation, we can see it now that there is being reduced to carbon dioxide, reduced to carbon dioxide, reduced to carbon dioxide. But we need to note that the production of the product of combustion or oxidation of carbon dioxide to carbon dioxide firmly by its ability to turn lime water milky. Sorry. Now shortly, synthetic gas, like water gas, synthetic gas is a mixture of carbon dioxide and hydrogen. Synthetic gas, just like water gas, is a mixture of carbon dioxide and hydrogen gas. It is obtained by passing natural gas, which is methane, over a steam or air in the presence of nickel as a catalyst, and is given in a mixture of this. As we can see, carbon dioxide and hydrogen gas is given there. Methane again. This is supposed to be methane, and carbon dioxide and oxygen. Carbon dioxide and hydrogen will be produced. A mixture of carbon dioxide and hydrogen gives us a synthetic gas, or we call it water gas. Now let's talk about the separation of the producer gas and water gas. Producer gas is a mixture of carbon dioxide and nitrogen, while water gas is a mixture of carbon dioxide and hydrogen. So it's not this. Fuel, note, a fuel is any substance that supports burning or that burns in air or oxygen to produce heat and light. Producer gas and water gas are examples of fuel, solid fuel or wood, coal and coke. All of them are examples of fuel. So anything that can any substance that can burn in air, we call it fuel in chemistry. All right, liquid fuel, example, producer gas, kerosene, alcohol, methylated spirit. These are examples of liquid fuel. Gaseous fuel, we have producer gas, water gas, coal gas, natural gas, paraffin oil, and the synthetic gas. Human fuel, we have something like food items in the form of fat and oil, protein, starch, and sugar. But atomic fuel, we have uranium as an example. Let's look at a little of this. Metallic preparation of insoluble triazo carbonate, 4 salts. We need to understand that all triazo carbonate 4 salts are insoluble in water, except that of the sodium, potassium, and the ammonium. All others are insoluble, but these are soluble. Others are insoluble, meaning that these triazo carbonates that this is soluble, but others, this one, copper carbonate, copper 2 carbonate is not soluble, zinc carbonate, they are not soluble, but other, lot of the sodium, potassium, and ammonium carbonates are soluble. Then properties of such kind of salt, all salts, triazo carbonate 4 salts are soluble, except this of potassium, calcium, and the ammonium. I've said it before. They dissolve in water to produce alkaline solution. This is because they are source of strong bases and weak acids. Hence, they hydrolyze in water to produce alkaline solution. With the equation given below, we can see alkaline, potassium hydroxide being formed, and acid, weak acid, strong base and weak acid. All triazo carbonate salts, except those of potassium and sodium, decompose on heating. They decompose on heating, except that of the sodium and the potassium once again. That of the sodium and potassium, which is sodium carbonate and potassium carbonate, are not affected by heat or by heating to liberate carbon 4 oxide and water. To liberate carbon 4 oxide, but those of other ones do that. Chemical test for carbonate salts. Test on liquid or solid dry test. Small solid sample, when you get a small solid sample of salt and it's been put in a test tube, and a few drops of dilute hydrochloric acid is being added or was being added on it, effervescent occurs. If effervescent occurs, then an odorless, colorless gas was given off, which turned moist blue litmus paper slightly red or turned lime water milky. Such kind of gas that will do that is carbon 4 oxide. You know that carbon 4 oxide is being gotten, comes from carbonate, triazo carbonate 4 salt. It's being gotten, it evolves from carbonate salts. So that is the liquid test, or solid, we call it dry test. Okay, wet test, we call this one wet test when we use barium chloride solution. Barium chloride solution was added to a few drops of solution of salts in test tube. A white PPT was formed. If such a thing is formed, a precipitate is soluble in dilute hydrochloric acid to give colorless solution. In that case, we can conclude that carbon 4 oxide is there. All right, let's look at the carbonates, triazo carbonates 4 acids. Triazo carbonates 4 acids. This acid is a very weak acid. It's a weak acid of diabasic acid. It's a weak acid and it's diabasic. It is obtained when carbon 4 oxide dissolves in water and is unsuitable, hence never isolated. We can see the way it's been formed. When carbon 4 oxide is dissolved in water, it produces it. The acid form both the normal and the acidic salt. It can form normal salt, it can form an acidic salt. Uses of triazo carbonate 4 salts. Sodium carbonate is used in softening hard water and in making soap and glasses. And the calcium carbonate is used in making quicklime, cement, and glass. For further discussion, just do well to contact me through my WhatsApp line or phone line, +234 80 or with my email address at christo116@gmail.com. Thank you for being part of this class, and get ready for the next video. Thank you and being blessed.